Hello, in this video we are going to see how we can do an end-to-end deployment of two SAP HANA servers with HANA system replication, and on top of it we will build a Red Hat pacemaker cluster to automate the failover of the system replication in case of failure. We are going to use Ansible to automate all this and perform the whole end-to-end process. And besides the Ansible engine, we will use the Red Hat Ansible automation platform, formerly known as Red Hat Ansible Tower, in order to have all our workflows there, all our playbooks, all our job templates, and all our servers in our inventories. So here we can see the login page of the graphical interface of the Ansible platform. Automation platform. There's a dashboard where we can see how many inventories we have, how many hosts, if there are hosts that have any issues, how many times we have executed jobs, and the statistics of the different jobs. If we go to the inventories, we have a group here that we have created for this installation. So it's called SAP hosts, and inside SAP hosts we have the general variables that apply to all the hosts here that will be used by the playbooks. If we go into hosts, we will see that we have two for HANA, where we will deploy the HANA databases, and one for S/4HANA that we will not use because the cluster we are creating today is only for the database tier. Inside of the host, we can see all the variables that will be used specifically for those hosts in the different playbooks that we're going to run in the workflow. With the, for example, we can see here the storage partition, etc. We have seen in the blog post series, automate your SAP HANA and S/4HANA application with Ansible. We have seen the whole workflow to create with end-to-end installation of SAP HANA and S/4HANA, not using Ansible platform, but using the Ansible engine. So it's the same, and we are using the same playbooks and the same workflow. We will just be adding two steps, one for HANA system replication and one for the creation of the pacemaker cluster. But we are just looking at the same playbooks that were used in that blog post series. This is the secondary HANA server. We will deploy the secondary database. And here we can see the different projects that we have created. So we create a project per playbook. So each playbook or each step that we are going to run will have a project associated. So we can see, as I just mentioned, the same playbooks that we have used in the deployment of SAP HANA or SAP S/4HANA. After creating the projects, we have to create templates that associate each template will be associated to one of those projects, and those will be the actual workflows that will be triggering all the playbooks to do the deployments. So in our case, we have the SAP HANA end-to-end deployment with high availability. If we look at the workflow visualizer, this is another feature of a Red Hat Ansible automation platform, that we can see all the pipeline that we've built, and we can add, and with drag and drop, add and delete steps that will be associated to these templates that we have just seen. As we said, we are covering the same steps. So we have two VMs with RHEL installed, and we will register them to the Red Hat Enterprise Linux for SAP Solutions channels with the SAP RHCM playbook that we have seen in the other blogs. We will then install first we will partition the disks and prepare them for the installation of SAP HANA. Then we will install the SAP host agent, and before that we need to first we will still install the SAP host agent, as I was saying, and then we will apply the SAP system roles that come with the subscription RHEL for SAP applications and RHEL for SAP solutions, in order to apply all the nodes that are necessary to install and run performantly SAP workloads on top of this operating system. So those are the SAP preconfigure that we can see there, SAP HANA preconfigure. And since we are not deploying an application here, we will not use the third system role, the SAP NetWeaver preconfigure. Then we have the SAP HANA deployment to do the actual installation, and then the SAP HANA You have SAP HANA system replication and the SAP HANA pacemaker steps. Here we can see the terminals where we are connecting via SSH to the virtual machines. We are going to run the installation, and well, since you have seen all this all this process up to the installation or the deployment of the SAP HANA nodes in the other videos, we will just skip these previous steps and will concentrate on the HANA system replication and pacemaker steps. Here we trigger the whole workflow. We're going to launch it. And as it runs, we will be able to see if we click on the details of each one of the step, or the step that's currently running, or a step that's been completed, we will be able to see the logs just as we would if we executed the playbooks in the machines directly, as we have seen in the other blocks. Those are the same type of logs, the same output that we get when we do it on the operating system. But as we said, let's say skip till the additional steps of the HANA system replication and the pacemaker. Just before that, we will see that the HANA databases have been actually installed already in the servers, so we can just SSH them and see that the SAP HANA processes are running with the SAP HANA administrator user, RHA ADM in this case. There we have the first server, HANA 1, with the SAP HANA deployed and running. Then we'll SSH the other server, HANA 2, and we'll do the same. We've called the installation RHA, that's the HANA instance. Should be the same SID for both, because we are going to enable the HANA system replication. And now we'll look at the execution of the SAP HANA system replication playbook. We have that it succeeded, and we have all the tasks there. So triggering the backup of the primary system that it needs to be taken before enabling the system replication, then enabling this primary host and registering the secondary host to the primary. And we will go to the operating system again and check with the Python scripts that the system replication is actually enabled, and that it has the correct status. And let's see the features that we have. This is the secondary database, and it shows that it's the mode of the replication is synchronous in memory, that it is registered to a primary site that we have called DC1, that's the HANA 1 server. If we go to that server and we execute the same Python script, we will get more details about the replication and its stages. And here we can actually see the services that are being replicated, the name server, the access engine, the index server, who's the primary, who's the secondary, so DC2, the ports that are being used for those servers, and again, the synchronous memory state or mode, and that the replication is active on both sides. Now if we look at the pacemaker playbook, it has also succeeded, and we have all the tasks as well, and the log there of what is done in order to create this pacemaker cluster. So all the installation of the agents, etc., that needs to be done, the creation of the different resources. And if we go to the operating system, well, the virtual IP as well, then when we go to the operating system, we will see that the cluster is actually there, and we will be able to run PCS commands. So those are the commands to control the pacemaker cluster of Red Hat. So if we check the status, just do a full status of the cluster, we can see everything that's been created. So 2 SAP HANA resources for the databases, 2 SAP HANA topology with the information of the HANA installations, and then the virtual IP, and then all the attributes of the nodes. So who's the primary or promoted, who's the secondary at the moment or demoted, the kind of the type of replication, that's the sync memory, the status, that's status okay, the HANA version, and yes, all the features of the resources, and if there has been movement in the cluster, so the migration summary, if there has been failovers, etc. So this is a way to enable or to do an end-to-end deployment of SAP HANA pacemaker cluster to automate the failover, the HANA system replication, and in order to protect the HANA systems of failures and to have a high availability HANA deployment. The whole process with Ansible takes about 30 to 40 minutes, so it's something that is really easy to do, and is, as you have seen, is just one click. So thank you for watching.